Hi, welcome. Today we're going to be working on this example here. Let's go ahead and read it. Suppose a company's revenue is given by R of Q equals negative Q to the third power plus 240 Q squared. And the cost function is also given, and that is C of Q equals to 200 plus 19Q, where Q is hundreds of units sold or produced, and R of Q and C of Q are in total dollars of revenue and cost respectively. So here are the questions on this side. The first thing that we're going to focus on is going to be to find the marginal profit function. And after we find that, we're going to use that function to find how many items need to be sold to maximize our profit. Once we find that value that maximizes our profit, we're going to actually compute it, and that will be the second part of this question here. All right, so let's go ahead and begin by answering part A. All right, so let's go ahead and turn our attention to part A of this problem, and they are asking us to find the marginal profit function. So for the marginal profit function, we have to remember that the profit function which we use P of Q is equal to, let's go ahead and continue here, this is going to be the revenue function minus the cost function. Now, because we are interested in finding the marginal profit function, once we find this here, our goal is to find the derivative of this function here. Now, if you guys remember from the given information, we do have the values of the revenue function and also the cost function. So let's go ahead and remember this here was given. We have R of Q, and if you guys remember, this is equal to negative Q to the third power plus 240 Q squared. And we were given the cost function, and the cost function was equal to 200 plus 19Q. Now, because here we have these two functions and they have more than one term, what I recommend you guys do is use parentheses so that we don't get confused here. So now let's go ahead and compute P of Q. So I will continue over here on this side. Let me grab the green marker here. So now we have P of Q is equal to, I'm going to go ahead and substitute my revenue function into the first part of this function here. So I'm going to take this here and use parentheses. So negative Q to the third power plus 240 Q squared. And now I'm going to minus my cost function, which is 200, and again use parentheses, plus 19Q. Now, the reason why using parentheses is very helpful here is because now we have a minus here in front of this expression, so make sure you are able to distribute this here and treat it like if it was a -1. When you have -1 outside, just multiply it times what is inside, and you should get rid of that parentheses. So on this side here, I don't have a minus outside, so it's going to remain the same. So now I have negative Q to the third power plus 240 Q squared. Now this is the part where we have to distribute this negative inside. So distributing this inside, that gives me negative 200. Distributing this to the second term over here gives me minus 19Q. Now, do we have any like terms here? Well, from the looking at this, we do have Q's, but if you look at other terms that contain a Q, they have different exponents. So for that reason, they don't have any like terms that we can combine. But what I can do is maybe flip this to here so that I have it in order. So just to make it easy on us, I have P of Q is equal to negative Q to the third power plus 240 Q squared. Again, I'm going to move this here so that I have all my Q's in descending order. And finally, my constant over here. So now we have the profit function. Now, if you guys remember, what we were asked to find is the marginal function, the marginal profit function. So the marginal profit function is basically the derivative of my profit function. So what I need to do now is take the derivative of what I just found here, and that will be my solution to part A. So again, this is my profit function. I am going to be using this here. So let's go ahead and compute the derivative of this here. So using the derivative techniques here, I multiplied 3 to the negative 1 in the front. That becomes negative 3q to the second power. How about this? You bring this 2 to the front. That gives me 480q to the first power. How about here with the 19? We do have a q here. So we are going to end up with just a negative 19. And here is my marginal profit function, which is my solution to part A. So let me just finalize this by saying this is the answer to A. Now we're going to go ahead and continue with part B. Okay, so now let's go ahead and turn our attention to part B now. Part B is asking how many items need to be sold to maximize profit, and what is the maximum profit. So whenever we are asked to find the minimized or the maximized of a function, you want to make sure that you remember the definition of the critical numbers. So critical numbers, I'll go ahead and write it here. Again, we did find the marginal profit function, which is over here. So for this problem here, the critical numbers are going to be what values of q makes this here equal to 0, or what values of q makes this here undefined. Now, if we take a look at part A here, we do have a polynomial. So because there's a polynomial, it's going to be continuous everywhere. So we don't really have to worry about this case here. What we really want to find out is what makes this function here equal to 0. So what I'm going to go ahead and do is I'm going to set the marginal profit function equal to 0. So basically get this here and set it equal to 0. So here we have 0 is equal to negative 3q to the second power plus 480q minus 19. Now if you guys remember this from algebra, this is where we have to go ahead and factor to solve for q. So we're trying to make this here into a multiplication so that we can maybe use the zero factor theorem and solve for q. Now looking at this problem here, it does look like the terms here are going to be a little complicated. So what I'm just going to go ahead and do is use the quadratic formula. So if we remember the quadratic formula, I'll go ahead and write it here. Quadratic formula. For this case here, because we're doing it in terms of q, this is what we want to remember here, negative b plus or minus square root of b squared minus 4ac all over 2a. So this will be a long process, so let's go ahead and do it part by part here. So the first thing we want to focus is identifying your a, b, and c to use the quadratic function. So looking at this function here, I have a is equal to negative 3. Again, if you guys don't remember, we are looking at it from this here. 0 is equal to a x squared plus bx plus c. So in case we forgot, how do you get your a, b, and c? Well, you have this in standard form. You basically make the connection between this here and identify your a, b, and c. Now here b is equal to positive 480 and c is equal to negative 19. From here, we'll continue to use substitution and using this quadratic formula that will give me the zeros that I need to make this a true statement. So we're going to go ahead and continue. All right, so let's go ahead and continue by substituting these values into my quadratic function here. So then we're going to have q is equal to negative b, which is going to be negative 480 plus or minus square root of b squared. Again, b squared is this here. So that means 480 to the second power minus 4 times a, which is negative 3, times c, which is negative 19, all over 2a. 2a is going to be 2 times negative 3. So using our calculator here, we can see that this is going to be negative 480 plus or minus square root. We take our calculator and do 480 squared, and that's going to give me, once you do everything, 230,172. All of this divided by -6 when you multiply. So again, to get this number, just make sure you use your calculator, square this here, find out what this is here, but be careful with the minus sign. That does tend to make people do easy mistakes, so just be careful there. All right, so now that you have this here, we'll go ahead and continue to simplify this here. And this is going to give me negative 480 plus or minus 479.76 all over -6. So notice that we do have the plus and minus here. I will go ahead and take care of both cases. I'm going to start with the positive case. So negative 480 plus 479.76 all over -6. Don't forget this is negative here. And this will give me an answer of 0.04. Now I also have the case for negative, so I will compute this in just a second. And for the negative case, I have negative 480 minus 479.76 divided by -6. And this will give me a value of 159.96. Oops, that's a really bad. And here's my focus here. Okay, so now that I use the quadratic formula to find these values here, I am going to go ahead and use the color pink here to identify my critical numbers. Now, how do I know that these are my critical numbers? Well, we can verify this information by using this here and plugging it into our marginal profit function to see if that does in fact make it equal to 0. And you will see that this actually does give you zeros. So we're going to go ahead and continue to use these numbers here. All right, so let's go ahead and continue with part B here. We were able to successfully find our critical numbers. So now the plan is to use the second derivative test to verify that these are in fact maximums or a minimum. So to do that, we go ahead and take the first derivative here, or the second derivative, I should say. We already have the first. So taking the derivative of this here will give me, again, 2 comes to the front, so we have -6 q to the 1 power plus 480. The q will go away. Here we have a constant. The derivative of a constant would just go away. So now what we want to do is apply the second derivative test to verify that this here are a maximum, which is what I'm interested in. Now, how do we check that? Just to give a little review here. If we plug in these points in here and I get something positive, that is going to imply that this is behaving with a concavity going up. So if it is concave up, that means that we are going to have a minimum at this value here. Now, if I plug it in and I get something negative, that means that this is concavity downward. And if it's concavity downward, that is going to imply that at that value we have a maximum, which is what we want. So let's go ahead and see what happens when you plug in the first value here. So if I get this value and I plug it into my second derivative, I get -6 multiplied times 0.04 plus 480. As I can see here, plug this into your calculator, and we get 479.76. Now, this is going to be a positive solution. So again, what does that mean? That means that this is going to be concave up. And if this is concave up, at this point here, we have a local min. Is that what we want? No, we want to find the value that's going to maximize my profits. So this is not a value that I want to look for. So now let's go ahead and see if 159.96 is a maximum, which is again what I want. So to check that again, we use the second derivative test. So we're going to go ahead and plug this into the second derivative, 159.96. So everywhere I see a q, I will go ahead and write that down. So 6 times 159.96 plus 480. By plugging this into your calculator, I have 479.76. And this is negative. Because again, just to verify, -6 times this here is going to give you a bigger number than this here, and it will be negative because you're multiplying negative times positive. So because this is less than 0, that means we have concave down at this value here. And if we have concave down, that will in fact verify that when Q is equal to this number here, we are going to round it to about 160. Here is going to be a maximum, which answers the first part that we were looking for. So again, why am I using 160 and why am I not using 159.96? Because when you are buying something, you should buy as a whole unit. You don't buy to a decimal. So for that reason here, I just rounded this up to about 160, which is what you should do. All right, so now that we were able to find how many units we have to sell to maximize our profit, we had the other part to this question, which asked us to find how much that was. So let me go ahead and erase this here and continue to show you that. All right, so now for this part here, I did want to bring back the other information that we have. We started with the profit function, which is here the original. Then we have the first derivative, which we found, and the second derivative, which we also found. So now we know the number of items that we have to sell to maximize our profit, but now the question is, where do I plug it in? Which one of these here do I use? Remember that the profit function is going to be the first one. So for that reason here, everything about this function is giving you the information that you want for this question here. The first derivative, we only used it to find our critical numbers. Why do we want critical numbers? Because those are possible maximum and minimum values to this function here. Once we find the critical numbers, we found the second derivative to help us verify that the values that we found from the first derivative, which are my critical numbers, were in fact a maximum or a minimum. We were able to rule out 0.04 because that was not what we want. That would be a minimum. We are focused on the maximum, so we plugged in 159.86, which was the second critical number, and that gave me a maximum. So now to get the actual profit, we have to go back to the original function. We cannot use this here. That will be incorrect. So again, to see how much we're going to make, if you guys remember, this is your total profit. So what we're going to go ahead and do is plug in this value into our original. So that means P of 160 is equal to negative 160 raised to the third power plus 240 times 160 raised to the second power minus 19 times 160 minus 200. So using our calculators here, when I go ahead and plug this into your calculator, I have negative 4,096,000. Then I continue to plus 6,144,000 minus 3,040 minus 200. Adding this all together give me a solution of 2,044,760. And remember that this is profit, so I'll put a $sign there. And this is what we will create profit with our maximum value, which is 160. And this will be the solution to part B.